Hi, I'm Jelle, and I'm all there is today. So for this video, I'm going to show you another way to approach parallelism, and that's with Azure Batch, which is more of a more complex, more ambitious way of tackling the problem of parallelization. So we can have a look at Azure Batch documentation on Microsoft, where it will tell you all about high performance computing, and you can look what Microsoft has to tell about how Azure Batch will solve parallelization problems for you. But for this, I'm more interested in how Azure Batch approaches the developer side of things. So how I, as a developer, should get it to work. What I've done is I've created some Azure resources which are necessary for running. I've also created a bit of a sample code project with some code decisions that I would advise you to take into account if you approach working with Azure Batch like I do. What I'm not going to do is actually start running, because as opposed to, for instance, using the fan out, fan in process with Azure Functions, where you could also achieve parallelization, it's not really, it's not like a click and run kind of application. There's, besides a lot of setup, there's also a lot of overhead. So if you have a very quick task that you want to make sure that it runs parallel, and the task isn't very complex, so the parallelization is basically pleasing or embarrassingly parallel, I would advise go the fan out, fan in route. But if you're looking at tasks that can run parallel, but they have like interdependencies or a lot of communication has to run through, that's when the overhead that Azure Batch has is cancelled. You can, I would advise looking at Azure Batch and making sure that that may be more of an appropriate choice. So if we're tackling the more complex parallelization problems, that's where I would say Azure Batch is more of a match. So what I've done in the portal, or via the CLI or however you want to approach it, we create a batch account. And you need to associate that with a storage account. So the storage account is just your basic average blob storage account. It will contain some of the files necessary for Azure Batch to run, but it's also a logical place, but not a necessary place, to put some input for your tasks, or you can even write output to that storage account. You can also choose to use a different storage account for that. So the batch account is actually something different. So what we have in the batch account, what we're looking at here, is, let's look at the features here. So we have all kinds of settings, and when you create a batch account, just look at the documentation for that. There are all kinds of settings that you can configure. Most of the default ones are usually fine. You can set up some high-end security and networking stuff, because this is all targeted for the complex parallelization jobs. So maybe you want to make sure that not everyone can access everything. Probably you do. And one of the most important features, you can either do this in your batch account itself, or you can do this on a per pool or even per job kind of basis. You can add application packages. So in the most basic Azure Batch runs, you would ask a bunch of nodes or VMs basically to execute a application package, and this can be a zip, for instance, as here, which in my demo it will turn a video file into a audio file. It would be a lot harder to do it the other way around, so this is the only thing it can do, unfortunately. But it will do this for a node will perform a conversion of a video file to a audio file, and in the end you'll have a bunch of audio files. So there's no aggregation or post-production necessary here, but Azure Batch can function very well for those kinds of workloads too. In my example, there's not going to be any very interactive stuff, because if you take a video file and you turn it to an audio file, you don't need to look at a different video file. But it is very possible for a task to do that, and it will take the video file from the storage account that I mentioned earlier, so there is some interactivity there. So how does the batch account hierarchy work? Well, basically we have 0 to n pools in each batch account. Pools can be made from the portal or in any typical way, or you can create one using your code. The first time creating a pool, that takes a while. Reusing a pool, that's very quick. And within one or more pools, which has settings like the number of nodes it can use and the type of nodes it can use, within those pools you can have jobs. So a job is basically a collection of tasks, and each task is run on a node within the pool to which the job belongs. So I actually still have a job here which has the great name my job, which existed in the my pool. The my pool is gone, but you can still look at the job and what it did. So this is actually a previous run. I would advise creating pools and jobs from code, so you can actually interact with them. So either use YAML or Bicep for that, or use, for instance, what I've done, use your actual C# code. So let's take a look at the application. So what I have here is a basic console application, and we're gonna look at the program here. I've tried to provide as little overhead as possible, but there is some overhead, and that's actually one of the, let's call it a feature of Azure Batch. So there is going to be some overhead, and we're going to see that. So it's not as easy as just fanning out and running and going back. We need to configure some stuff. But it also gives us much more control on the kinds of jobs and optimizations that we want to do. So basically what we see here is in the program, we're going to run the app. And in the app, we're going to use some dependency injection to get a storage service and a batch service, which I guard against null. And I'm going to leave those a bit black boxy for now, but within the batch service class is actually the code that directs Azure Batch, and that's what we're most interested in here. But first, let's take a look at what the actual program does. So what we have is we start a timer, right? So that we know how quick it was. We make sure that the storage is in the condition that we want it to be, and we get some input file paths. So we actually have 5 beautiful video files here, and we're going to make our end goal will be to turn those into output audio files and upload those to the same storage account that we're using to upload these input files to. These local files, they need to be present in the storage service. So that's what this line of code does. And we're gonna make sure that each and every of the nodes, each and every of the VMs is able to access that storage location, because otherwise the storage service would be like, yeah, you can't access that video file, and we kind of need it if we want to turn it into an audio file. We're gonna make sure that we get some configuration, and then the batch service class, which is disposable, is going to do its magic. Basically, we start a job, which if I look into that, it creates a pool, which we mentioned earlier, the pool. If it doesn't exist, if it exists, it's really quick. Then we create a job within that pool. If the job already exists, it will throw an error. And then we add tasks to that job, given the batch job configuration that we have. And each task will be a specific instruction to turn a video file, a specific video file with access into a specific output file, which is basically what we have here. and then it will also know where to store that output file. We make sure that these tasks are actually added to the job, and basically what we have done here is we have the overhead. So we have created a job, we have created tasks. The only thing we haven't prepared yet, and which we're going to let the Azure Batch prepare for us, is all those nodes. We're going to ask the batch service to monitor the tasks, and that's when basically we get an await task when all kind of construction, and we tell Azure Batch, all right, you know which tasks I want to be done. Inform me please when they're ready. Now of course you could you can have some configuration options here. You can make like I have written a small timeout flow, but you can be more or less precise if you want to. So in our case, this is not going to be a very long job, and the tasks are going to be done pretty quickly. But these can be very long running tasks, and you can also set up that if one of them fails, you'll only retry that one. Depending on how well written your code is, you could even do retire mechanisms within a task. All right, so we're going to assume that the job completes, and when it does, we have a job result. So either it's completed, or it's cancelled, or it has had an error, and this application will then inspect whether that was a good thing or a bad thing, and it will then ask whether it should delete all the stuff like batch resources, input files. This is not necessary, but especially since multiple jobs with the same name or multiple pools with the same name will give an error, it's a good idea to do this. We would need to look at the configuration itself, which can be found here, and we can see stuff like, all right, we need a job ID, and we need pool IDs, we need resource files, we need the output location and access, but we also have a different kind of configuration, so to say, where we are interested in how the job and the account, or how the code and the account, the batch account, can find each other. So these are, in this case, in the settings, where we can find batch settings. So for connecting to a batch account, you'll need a name, a key, a URL. As we know, for a storage account, you'll need a name, a key, and one or more container names. And for a batch job, you'll need to specify whether that job will use a certain one of the applications that you've uploaded, which version of that application, the VM size, so the kind of VM that you would like to use for the task, and there's a lot of tweaking involved here, and whether you're using dedicated nodes or low priority nodes, or as Microsoft is moving away from low priority spot VM node counts, you'll have to specify that to the job, how many VMs, because it's not a one-on-one relation necessarily with a task. Maybe you want one VM to run multiple tasks. That's also fine. If we're going to take a look now at the batch service that I mentioned earlier that we're going to dive into, this is what we're seeing here. Basically, we inject some of the settings that we wanted, and then we open a batch client. And this is the actual code that, if you're using the batch NuGet package in C# at least, you'll get this class, batch client. And it needs some credentials, which basically are just reformatted settings that I mentioned earlier. And that's where we get those, where we get the worker that allows us to interact with the account itself. So it has job operations and utilities. As long as we dispose it after the job is done, that's all fine. You can terminate jobs in the case of a timeout, and we can use the batch client also to examine or restart certain parts. The code, this exact code is actually, I'll link it at the bottom of this video. I would urge you to download it. You'll have to create some Azure resources yourself, but yeah, running this specific application in Azure Batch is really not expensive. You'll have to work out maybe some complicated quotas that you'll run into, because usually just, telling Azure I want to use 500 VMs, that sets off some kind of alarm bell, at least in the cost department. So you're protected against it by having a lower quota by default. But if you set those correctly, I would be very interested to hear who gets this running and who will have a beautiful collection of not video input files, but five audio output files at the end in their storage account. So Azure Batch, I would recommend looking into this just to wrap your head around, high performance computing, best jobs, parallelization in a way that's not as low maintenance as perhaps durable functions, but it also has a lot more configuration options. It's very possible, not easy, possible to have tasks interact with each other and interact with a lot more Azure resources. And it's also really fun to get this working. So check out the code. Thanks for listening, and I'll see you soon. Bye bye.